Hello there, my name is Lily Butman and I'm going to introduce you to various types of machine learning. At the end of this video, you should be able to understand the difference between supervised and unsupervised types of machine learning. Have a grasp on classification, regression, and clustering use cases, and develop intuition about the most appropriate technique to use for various machine learning tasks. It is common to group machine learning algorithms into three broad categories: supervised learning, unsupervised learning, and reinforcement learning. The majority of machine learning uses supervised learning. So what is supervised learning? If you're learning something under supervision from somebody, it means that you have an example. Someone is present judging whether you're getting the right answer. In the human world, is equivalent to a full set of labeled data that trains the algorithm. In the machine learning world, it means that you have a full set of inputs and outputs that you can learn from how to get the task right. In classification tasks, we have a set of data points, input and outputs. The inputs are various values that describe the data point, in this case the person. The output has to be categorical, in this case male or female. After training on the training data set, the algorithm has to correctly classify the various data points into male and female. This is the essence of supervised learning. Another good example of supervised learning is spam detection. There are various emails. This is the input. They have to be classified into spam and non-spam. This is the output. So the algorithm will learn. It will have a set of correctly classified emails, and then we'll do some testing, see if it learned enough in order to classify correctly the non-classified emails. So we discussed supervised learning in the context of classification tasks. There are, as you can see, also regression tasks. Both of them have a learning process with inputs and outputs. As an example, in classification tasks, the outputs are categorical, whereas in regression tasks, the outputs are numerical. The classic example of a regression task is housing prices. A training dataset with inputs and outputs, prices and sizes. So we use the training dataset in order to teach the algorithm which size of the house is associated with which price. And then we use the testing dataset to see how well the algorithm learned. We can see how good is our model by comparing the outputs from the model to the real prices of the house. So we looked at the world of supervised learning, classification tasks. Is it a man or a woman? Regression tasks. What is the price of the house according to the size of the house? And now we leave the supervised learning world and we enter the unsupervised learning. But there's no example, no labeled set, only inputs. And when only inputs are there, What we can do is find patterns, associations, similarities, clusters in the data. This is an example of a clustering algorithm result we are very familiar with. Top picks for Joshua are based on the movies Joshua saw already. These movies belong to the same cluster as his previous choices. Each movie has many inputs. It has actors. It has a director. It belongs to a genre. And according to all of these parameters, the movies are classified into clusters. And then, because you watch Narcos, you get all these other recommendations. Let's see how these different use cases give us slightly different solutions. We will look at all of them: classification, regression, and clustering, with an example of runners. So let's assume we have inputs and outputs. For every pair of legs, we have his or her weight, height, the speed he or she is running in, and heart rate measured. In the training set, we also have the gender. So we feed it into the algorithm. So we teach the algorithm. Maybe the algorithm deduces that specific height is usually associated with males, let's say more than 2 meters or 6 feet. Maybe it deduces that a very petite build is associated with a female. Maybe a combination of speed and heart rate is associated with female or male. After the training phase, we do the testing. We feed it the inputs, which are only weight, height, speed, heart rate for each pair of legs or data point, and we get the classification to female or male. Now, if it's a regression assignment, then we have still weight, speed, heart rate, and height as inputs, and we have the result, which is numeric. How fast they ran the marathon, how many hours it took. So this result is numeric. It's a regression task. Maybe higher people have longer steps, so they tend to run marathon faster. Maybe when the heart rate is high now, it means that they will have to decrease the speed later, and this has to do something with the result, etc. After training, the algorithm will be able to predict the results in the testing data sets. It's interesting to know how well it will predict them. This is regression. We feed it the inputs, same inputs, and we have the result, what will be the time in the marathon, as the output. In clustering, still same inputs, no output. Weight, height, speed, heart rate. And we give the algorithm the number of clusters we expect. Maybe it would cluster the runners according to advanced or pro runners versus amateur runners. Maybe the combination of speed and heart rate is very different for pro runners. Maybe it will cluster them according to age groups. Maybe different age groups has different weight, median, and mean. How many we have to specify how many clusters we expect, and the way the algorithm will group the runners might surprise us, but this is clustering with multiple inputs. Let's try the intuition that we developed for supervised learning, unsupervised learning, and regression, classification, and clustering tasks in a new task. Okay, so the task is to predict which woman is considered beautiful, what face actually is considered beautiful by a human. What I want you to think is what type of technique was used in order to teach machine learning to do this separation. I don't want to say the C word. So take a minute and consider, is it a clustering task according to some facial characteristics? You would ask the algorithm to cluster the similar faces together. Would it be a regression task with some kind of a numeric score for each one of the faces? Or would it be a classification task where the algorithm will be asked to classify, is it beautiful or less beautiful in human perspective? The truth is, all three methods can work, and the beauty of machine learning is that you have to try which one gives you the best results. But what was done here, it was a classification task. You can see A and C is the training data set where a human classified A as beautiful and C as not so very beautiful faces. And then B and D is what the computer did with the testing data set. I want to part with leaving you a new use case, face recognition, and I would like you to think, is it a classification task, regression task, or clustering task? Thank you. Goodbye. Okay, so we're almost done